Assalamualaikum, my name is Afika. I will present the introduction. And for our report, we focus on two projects, which is E-Metro Logistic Park and Project Sapphire Subang Jaya. And in this presentation, we will discuss on type of piling use, method of construction, challenges of the projects, and the solutions. I will talk about the background of Project 1, which is E-Metro Logistic Park that located in Bandar Bukit Raja 2, spanning 177 acres, and the funding is supported by SD Plugs Syariah Compliant Industrial Development Fund. This is a joint venture between Sam Darby Property and Logos Property. The total area is 8 million square feet, and the type of piling used for this project is span piles. The parties involved is developer plus PM consultant and the design and build contractor, Sunway Construction. Next is background of project 2, which is Sapphire Subang Jaya. It is located at Subang Jaya, spanning 40 acres, and the total area is 3 million square feet. And the features of the project includes green spaces, retail outlets, and contemporary residential towers. And the type of piling used for this project is board piles. And the parties involved is lead consultant Jurutera Perunding YLT.
Good morning everyone, my name is Fatin Nabiha, and now I will proceed this presentation with two types of piling used in project 1 and 2, span pile and board pile. We will discuss their types, specific details, and their method installation of the pile used in two different projects. Firstly, let me give you a brief overview of both piling methods. Span piles are created through a spinning process, resulting in high-strength concrete piles that are precast and ready for rapid installation. They offer excellent durability and load-bearing capacity, making them ideal for heavy structures. On the other hand, board piles are constructed by drilling a hole into the ground and filling it with a concrete and steel reinforcement, and these piles can be installed in various soil conditions, although they are more time-consuming to construct compared to span piles. Now let's get into the specific pile used in project 1, which use span pile. In this project, the span pile is denoted as P400. This refers to 400 mm times 400 mm span pile with a working load of 148 tons, and the piles are to be driven to a set depth with a provisional length of 39 meters. The table of height tensile spar for span pile specifies the reinforcement required for two different pile diameters. For 250 mm diameter piles, 4 bar of 12 mm diameter and 500 mm length are used, and for 500 mm diameter piles, 6 bar of 16 meter diameter and 900 mm length are utilized. These details ensure the structural integrity and load-bearing capacity of the span pile. Now let's move on to project 2, which uses board pile. The table provides detailed specification for board pile, including 3 different diameters: 1350 mm, 1800 mm, and 2000. All piles use concrete of grade 40, and the length of the board pile in soil are 47.4 meters for the 1350 mm diameter and 59.3 meters for 1800 mm and pile and 64.5 meter for 2000 mm pile. We can conclude that both span pile and board pile offer a unique advantages and are suitable for different construction scenarios. Span pile provide a rapid installation and consistent quality, while the board pile offer versatility and minimal vibration, making them ideal for urban area. Next, I will be explaining about the method installation of span pile that are used for project 1. The installation process begins with site preparation. They will conduct a detailed site survey to determine the exact pile location, clear the site from obstruction, debris and vegetation, level the ground for machinery movement, and mobilize and set up necessary equipment such as pile driving rigs and cranes. Next, we move to pile positioning. The crane lifts the spun pile from horizontal to vertical, position the pile over the marked location, use alignment tools to ensure the pile is vertically aligned. Next, the actual driving of the pile will involve by initial driving to insert the pile into the ground, ensure it remains vertical, continue driving until the pile reach the required depth or bearing capacity, and adjust the force and frequency of the hammer to optimize penetration. If the required pile length exceeds the standard length, cut the end of the driven pile to ensure a flat surface for splicing. Align and connect the next pile section using steel sleeve or other technique. Drive the spliced pile section to the final required depth. Quality control and testing are essential to conduct, as they will conduct a test to verify load bearing capacity, perform pile integrity tests to ensure no defect within the pile, and lastly, the pile finishing will be conducted by installing pile caps or connecting piles to the pile cap structure, cleaning the site and removing debris, conducting a final inspection, and preparing documentation. In conclusion, the installation of spun pile required a good planning, precise execution, and true quality control to ensure a stable and durable foundation. By following this step, construction project benefits from the reliability and strength of spun piles.
Assalamualaikum and hi, my name is Fida Warida binti Azhar. I will now continue this presentation with the method of installation of pile for the second project, which is the project Sapphire Subang Jaya. This project uses ball pile. The first step of installation is the preparation phase. This involves setting out the work and mobilizing equipment, where surveyor marks the exact locations for each pile, ensuring precise alignment and positioning. Following that, all necessary piling frames, equipment, plants, and tools are transported to the site. Next, we move on to the boring process, which is crucial for creating the boreholes for the piles. We start by drilling vertical holes from the platform level through various soil strata. Then, temporary casing is installed and extracted to maintain the borehole's integrity. Once the boring is complete, we proceed to install the reinforcement cage within the borehole. The reinforcement details, including main reinforcement bars and spiral links, are meticulously assembled to match the pile diameter specifications. Following that, the reinforcement cage is lowered into the borehole, ensuring it is positioned correctly and securely to provide the necessary structural support. Moving on to the next critical step, which is pouring of concrete into the borehole. Ready-mix concrete is then poured using a 3mm pipe to avoid segregation and ensure a continuous pour. The concrete must be vibrated appropriately to remove any air pockets and ensure full contact with the reinforcement and surrounding soil. After the concrete has set, we will trim the pile head to the required cut-off level. All debris from the trimming process is removed from the site as well. Finally, various tests such as height, strain, dynamic load test, and pile integrity tests are conducted to verify the quality and performance of installed piles, ensuring that the foundation's overall integrity and stability. In conclusion, the installation of bore pile is a meticulous process involving several critical steps from preparation to the final testing. Next, we are going to move on to the next part, which is the testing and inspection of piles. Testing and inspection for piling are essential to ensure their structural integrity and performance. Firstly, for the first project, they have used 3 types of testing on all sides of pile use, which are preliminary maintain load test, maintain load test, and lastly, pile driving analyzer test. Firstly, preliminary maintain load test involves applying a load up to 2.5 times the design working load to the pile before main construction begins. This test verifies the load bearing capacity and observes the pile's behavior under extreme loads. This test is conducted to help ensure the pile does not exhibit excessive settlement or signs of failure. Next, the maintain load test is conducted after pile installation, applying a load up to 2 times the design working load. This test confirms the actual load bearing capacity of the pile and ensures it meets the required specification. This helps identify potential issues such as excessive settlement or structural weakness. Lastly, the pile driving analyzer test is a dynamic load test used to evaluate the capacity and integrity of spine concrete piles during or shortly after the pile driving process. This test can identify defects such as cracks or voids that might not be evident through static tests. PDA testing ensures correct pile installation and performance under service loads. Now, let's move on to the second project. This project has conducted 5 different types of tests. Firstly is the preliminary test pile. The preliminary test pile is crucial for verifying design assumptions and pile capacity. This involves applying loads up to 2.5 times the pile's design capacity. The test includes installing the pile, attaching instrumentation, and applying load incrementally using hydraulic jacks. The data collected helps to analyze load displacement behavior, determine ultimate load capacity, and assess the pile's performance. Next, working test pile is conducted to ensure that the actual pile used in construction can bear up to 2 times their design capacity. This test is conducted on 1% of the total piles, following the same step as the preliminary test. The analysis verifies that the pile meet the design requirements and perform as expected under actual load condition. After that, the high-strain dynamic load test is conducted to estimate the pile capacity, integrity, and resistance distribution through dynamic methods. This test is performed on 5% of the total working piles, providing a quick and accurate estimate of pile capacity and identifying potential issues such as defect or changes in soil resistance. Next is pile integrity test. This test is to assess the structural integrity of concrete bore pile using stress waves generated by a small hammer and measured by sensors. This helps to identify defects such as cracks, voids, or changes in material properties within the pile. This test ensures the overall quality and reliability on the piles and is performed on 50% of the total working piles. Lastly, the sonic integrity logging test. This test evaluates the integrity and uniformity of concrete bore piles by lowering a sonic probe into a tube installed in the pipe. The probe emits sound waves and their travel, time, and attenuation are measured to detect defects or changes in material properties. This test is especially useful for detecting flaws from visible of the surface and is conducted on 2% of the total working piles. Thank you very much. That is it from me. I will now pass on this presentation to the next person.
Assalamualaikum, my name is Idina Dorisha. I will present about challenges in Project E-Metro-Logistic Park and Project Sapphire and the solution. Firstly, challenges using spampai that rise in Project 1, which is E-Metro-Logistic Park project in Bandar Bukit Raja 2 are: Number 1 is transportation challenges. Spampai known as the precast concrete pile, which is need the transportation of the product from factory to the construction site to be installed. In this project, the transportation is quite challenging because the pile are high potential to be broke if there is no adequate care or plan used for the transportation. Other than that, because the project is located at urban area, the busy road will cause delay for delivery the product. Number 2 is installation process issue. The use of plan and how to install the piles is one of changes that arise because the project is located at the urban area. The incorrect method of installation can cause problem and issue. For example, the method of installing the piles, such as vibration, can cause noise that appear during installation, which can cause problem with the people around there. Number 3 is safety issue. During shipping, loading, and unloading process, there has a risk of accident when handling and moving big and heavy loads. Lack of qualified workers in the project can cause hazard and unwanted event like structure collapse or failure of equipment. After that is changes in Project 2, which is Project Sapphire in Subang Jaya that using board pile in the construction. Number 1 is quality control. Quality control in board pile construction at Project Sapphire is changing due to the variability of subsurface condition. The project contains with unpredictable soil composition and presence of rocks which can affect the pile stability. Number 2 is ground issue. Groundwater control is critical for board pile installation process because the piling type environment must be tightly controlled. Same for projects of fire. High groundwater level pose risk of excavation instability and complication during concrete pouring. Number 3 is soil stability and excavation issue. Managing soil stability throughout the excavation process is changing in this project. As we know, deep excavation can disturb surrounding soil, particularly in high water content soil prone to instability. Using casing technique to maintain borehole integrity until concrete pouring can increase the construction complexity and cost. So the solution that can be applied to manage the problem in project 1 are: number 1 is improve the project planning. Implementing strict safety protocol during the transportation of spam pile for in-metro logistic park project is crucial. Utilizing specialized transportation equipment such as low bed trailer and crane ensure the safe handling of heavy and oversized load. Detailed route planning guided by through survey is essential to identify and navigate potential obstacles during transporting the product. Number 2 is follow the work specification. Access for specialized equipment and trained personnel is crucial for managing installation changes during the piling work of this project. By selecting updated pile driving equipment, which features such as vibration and noise reduction, the project minimizes disturbance to the surrounding environment and communities. Number 3 is enhance safety management. Conduct an effective safety management system can help for ensuring worker safety and minimizing risk during spam pile construction. Implementing frequent training on heavy equipment operation, material handling and emergency response prepare worker to work safely and efficiently. Strict instruction to safety procedure including the use of personal protective equipment (PPE) help prevent accident. Next is the solution for problems in projects fire are: number 1 is quality check. To make sure that there won't be any grout leaking while pouring concrete, construction worker must strictly adhere to all necessary regulation. A true analysis of any discrepancy in construction, as well as the use of building material and labourers on site, should be done on daily basis with attention to every detail. Number 2 is groundwater control. Reliable dewatering techniques such as sump pumps, deep wells and well points can regulate groundwater disruption while drilling is in progress. Number 3 is soil treatment and casing installation. Bentonite and polymer-based drilling fluids are examples of soil treatment that stabilize borehole walls as supporting layer that keep the walls from collapsing. Temporary steel casing can be placed to maintain the integrity of borehole until concrete is poured. So these are the recommendations for enhancing the process of construction in Project 1 that using spam pile. Number 1 is innovative installation technique. Implementing innovative installation technique for spam pile can help for optimizing construction efficiency at the e-metro logistic park project. Techniques such as vibration-free installation using hydraulic equipment can significantly reduce potential damage to nearby structure by minimizing ground vibration during pile driving. Number 2 is enhanced monitoring and maintenance system. Enhancing monitoring and maintenance system can help for ensuring the long-term performance and stability of spam pile at this project. By integrating advanced monitoring technologies, including IoT-enabled sensors, this project can continuously monitor parameters such as pile performance, environmental condition, and load distribution in real time. Next is the recommendation for Project 2 that using board pile in the construction. Number 1 is enhanced quality control. Adhering to specification for design and legal requirement throughout the construction phase is ensured by enhancing quality control procedures. Through testing, documentation and inspection procedures ensure the performance and quality of the piles. Number 2 is advanced drilling technologies. Installing drill pile with more accuracy and effectiveness is possible when advanced drilling technology is used. Drilling factors including depth, alignment, and soil condition may be properly controlled with automated drill equipment complete with real-time monitoring system. So that's all from me. Thank you.
Assalamualaikum, my name is Farah Yanada and now I will proceed with the comparison and contrast of the projects. Starting off with the similarities of Project 1 and Project 2. Firstly, both piles have a high load bearing capacity. The span piles in Project 1 and board piles in Project 2 exhibit high load bearing capacities, which is crucial for supporting large structures. This is because spun piles are created by rapidly spinning concrete and pre-stressing it, while board piles are formed by drilling into the earth and filling the hole with concrete. Both methods ensure the stability required for large construction, bridges, and industrial complexes. Secondly, both piles are efficient in construction despite using different construction methods. This is because spun piles are prefabricated and installed quickly on site, ensuring consistent quality and reducing costs. Board piles, however, are customized on site based on soil condition, which helps minimizing environmental impact in urban areas due to reduced noise and vibration. Thirdly, both spun and board piles are versatile and suitable for different construction environments. Spun piles resist corrosion and chemical exposure, making them ideal for maritime and coastal projects like Project 1. Board piles perform well in urban settings, managing difficult subsurface and condition effectively, as seen in Project 2. Lastly, both types of piles technologies are cost-effective due to their long-term reliability and low maintenance need. Spun piles withstand harsh environments with minimal upkeep, making them economical. Similarly, board piles maintain structural integrity in various soil composition, ensuring durability without the need for frequent maintenance. Moving on with the differences of Project 1 and Project 2. First, the construction methodology. The construction methods for spun and board piles are clearly different. Spun piles are made off-site using centrifugal spinning, ensuring precise dimensions and quality, which accelerates Project 1's schedule. In contrast, board piles are drilled and poured on soil, allowing for adjustment to specific soil condition in Project 2. However, it requires more on-site preparation. Next is the environmental impact and urban compatibility. Well, each piling method has a different environmental impact and suitability for urban areas. For example, spun piles cause minimal disturbance to soil and ecosystem, making them ideal for environmentally sensitive coastal areas like Project 1. Board piles, suitable for urban environments like Project 2, reduce noise and vibration, complying with strict urban construction regulation. Lastly, the testing and quality assurance. Different testing procedures are used for spun and board piles to ensure quality. In Project 1, spun piles undergo pile driving analyzer tests to confirm load-bearing capacity, ensuring safety and reliability. Project 2's board piles are subjected to high-strain dynamic load tests and pile integrity tests to assess concrete integrity and identify flaws, guaranteeing durability in different ground conditions.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aidi Akmal bin Ahmad Hulaimi. So today I will be talking about the cost analysis of piling methods for Project 1, which is spun pile. The cost analysis of this piling method provides a detailed examination of the financial requirement for different components involved in the piling process. This includes the provision and maintenance of piling equipment, which is essential for the successful execution of the project. The analysis covers the costs associated with dry piles, specifically 400 mm diameter vertical board piles, detailing the total number of piles, concrete length, maximum board depth, and additional expenses for boring through rock and using chimney pipes for concrete placement. For working piles, the analysis includes both 400 mm diameter racking and vertical board piles, as well as larger 600 mm and 800 mm diameter vertical board piles. This involves higher costs due to increased concrete length, deeper board depth, and additional requirements such as permanent casing for 600 mm piles and forming enlarged bases for 800 mm piles. The cost for preparing pile heads and reinforcement for capping, as well as both preliminary and subsequent load testing to ensure the piles meet required load-bearing capacities are also factored into the analysis. Additionally, the analysis covers the cost of fabricating and placing steel rod reinforcement according to BS 4449 standards, conducting integrity tests to ensure the structural soundness of the piles. In the case of spun piles, the conclusion of the cost analysis highlights that the spun piles tend to be cost-effective due to several factors. This includes reduced material costs, quicker installation times, and lower maintenance requirements compared to traditional board piles. Spun piles are also advantageous in various ground conditions, making them a versatile and economically viable option for many construction projects. The combination of these benefits makes spun pile an attractive alternative, contributing to overall cost saving and project efficiency. For Project 2, which is using board piles, the cost analysis of board piling methods provides an in-depth examination of the financial aspects involved in the piling process. It includes the cost for the provision and maintenance of equipment, essential for the successful execution of the project. The analysis covers the expenses associated with trial piles, detailing the number of piles, concrete length, maximum board depth, and additional costs for boring through rock and using chimney pipe for concrete placement. It also includes the preparation of pile heads and reinforcement for capping, along with costs for preliminary load testing to ensure the piles meet required load-bearing capacities. For working piles, the analysis encompasses 400 mm, 600 and 800 mm diameter piles, factoring in higher costs due to increased concrete lengths, deeper board depth, and additional requirements such as permanent casing for 600 mm piles and forming a large basis for 800 mm piles. Costs for subsequent load testing, fabricating and placing steel rod reinforcement according to BS 4449 standards, and conducting integrity tests to ensure structural soundness are also considered. In conclusion, the analysis highlights the cost advantages of spot. Alright, next for our project 2, which is using board piles, the cost analysis of board piling methods provides an in-depth examination of financial aspects involving in the piling process. It includes the cost for the provision and maintenance of equipment, essential for the successful execution of the project. The analysis covers the expenses associated with trial piles, detailing the number of piles, concrete length, maximum board depth, and additional costs for boring through rock and using chimney pipes for concrete placement. It also includes the preparation of pile heads and reinforcement for capping, along with costs for preliminary load testing to ensure the piles meet required load-bearing capacities. For working piles, the analysis encompasses 400, 600 and 800 mm diameter piles, factoring in higher costs due to increased concrete lengths, deeper board depth, and additional requirements such as permanent casing for 600 mm piles and forming a large basis for 800 mm piles. Costs for subsequent load testing, fabricating and placing steel rod reinforcement according to BS 4449 standards, are conducting integrity tests to ensure structural soundness are also considered. In conclusion, the analysis highlights the comprehensive nature of costs associated with board piles. While they involve significant expenses due to depth of boring, additional concrete, and rigorous testing to ensure structural integrity, board piles provide strong and reliable foundations suitable for various soil